Guess he's cool whenever. Hey everyone, welcome. Thanks so much for coming to our very first here of the Data Science Lecture Series. And we're really thrilled to have Vivienne Ming joining us. I thought I'd spend a moment to give you a quick introduction, also an update on bids, because I'm sure you're all have been following and are interested in what's happening. We're moving along with the space in 190.0, and in fact, this is the first and only of these lectures that will be here. They're still putting in ductwork as we speak, but the next coming lecture will actually be there. Even though we won't be fully up and ready for everyone to be working, we'll be able to start supporting lectures there in the space, and that'll be really cool. We're working on our actual website, so as I'm sure you've noticed, if you try to find information about us, it's still just a single page on the VCR website, but coming soon, so please bear with us, and that will make it much easier to learn about events and things that we're hosting. We do also already have, though, a great cohort of fellows. There are 15 amazing data science fellows with us. Several of them are here today, and Katie Heff will actually be following Vivienne's talk to help host question and answers, and so you'll get to meet her, and I encourage you to get to know those folks as well. And so this series will be bi-weekly, every other Friday at this time for the semester, and probably next semester we'll go every week. But what we thought we'd do to make things interesting is have a little introduction, have the speaker talk, and then have one of the fellows or an interested scientists help basically give a synopsis and Q&A afterwards to try to attempt this glue we've been talking about of having the cross-disciplinary researchers that are involved and trying to tackle all of the different backgrounds that people come from in attending these talks. So without further ado, I want to introduce Vivienne. She is a theoretical neuroscientist, a technologist, and an entrepreneur. She's chief scientist at Gild, who are using data and predictive technology to evaluate and identify technical talent. And as you can see, she's also a visiting scholar here at UC Berkeley. And I'll just say from a personal note with BIDS that I'm particularly excited about this talk. You'll be hearing more about our working groups, one of which is career paths and alternative metrics, where we're really interested in engaging on how data scientists' career paths might be better suited in the university and beyond. And so I think this talk is really well suited for that. So welcome and thanks.
Thank you. All right, thanks. So one of the challenges of giving talks on the kind of subjects I give talks on is that it's always hard to know the audience, gauge the audience. I found out a long time ago every equation you put up puts 10% of your audience to sleep, unless they're mathematicians, in which case it's the exact opposite. So I've kind of settled into this thing of really focusing on what drives me, which is the purpose of the work that I do. In which case, sometimes, and yesterday I was talking to the data science team at LinkedIn, and so I just say to the audience, I'm more than happy to talk about the technical details of the things I'm talking about, either in question and answer, to answer questions as we go along. So if something really grabs you and you want to desperately know how we manage all of the data we're talking about or what sort of algorithms we're using, please pop in with that. Otherwise, I tend to think in terms of the problem and how to solve it. And that's what really excites me. I'm pretty mercenary about the choice of algorithms or the specific approaches to solving them. What I care about is solving them. So let me start with this. A question. What is the economic cost of unrealized human potential? So think broadly about that. What is the cost that we pay, literally, societally, for untapped potential of our student populations, of young people, in the United States, globally? What is the cost of treatable mental health disorders, or health in general? What is the cost of having a workforce that's disengaged? That last one, I can throw a number at you. In fact, for most of these, I can throw a number at you because this has been a question I've been interested in answering for a long time because my interest is in driving that number to 0. And what's shocking is just back of the napkin, just looking at the United States, is an enormous number. It is how many times do you want to go back and forth to Mars every year? How many Googles and market cap do you want to build every year that we leave on the table because the investment of $1 today with the realization of a big payout in 20 years is simply not enough of an incentive to get people to make those kind of long-term investments. So keep that in mind as we're going through here. I'm going to talk about talent management. I'm going to talk about education. I won't be talking about mental health or healthcare, but as you'll see near the very end, I dabble in that space also. And these are enormous societal costs. You don't have to think of these as social justice issues, although I do. You can think in a very self-interested way, $1 in, $1 billion back. That's an investment. Think about what that would mean if this was a bond market. That would be the backbone of our economy, making those kinds of investments. Okay, so let's get right to it. Here's a guy named Jade Dominguez. Jade has an interesting story, and I know him personally well. So let's start with his history. He was a pretty good high school student, took AP classes and so forth. But who cares about that? Do you put AP classes on your CVs or your resumes? He didn't go to college for whatever reason. I never quite got the straight story on that, but he didn't. In fact, no one in his family ever had. Instead, he started selling T-shirts down in LA, where he grew up. Kind of entrepreneurially, like really had this idea, I'm going to sell some T-shirts. And then he figured, well, I can sell more T-shirts if I start a website. Didn't know how to program or anything, so figured out how to get a WordPress site together, put it up there, sold more T-shirts. And he thought, all right, but this isn't good enough. So he taught himself how to program. Picked something at random, Ruby. Taught himself how to program in Ruby. Turns out, a good choice for him. It's one of the main modern web application programming languages. Built a new site, sold a few more T-shirts. Wasn't good enough. Now he felt this itch. This site's not good enough. Really taught himself how to program. Started contributing to the code base of Ruby. This guy with no background. He had not a computer science degree, not even a dropout. Then he thought, why am I selling T-shirts in LA? I should get a job. I'm a developer. I send resumes. So he spent a year sending resumes up to Silicon Valley. Not a single response. He didn't get rejection letters. No one even replied to him. And I can really clearly tell you why. It's been actually studied very clearly, and it's just a subset of general human behavior. Recruiters, when working with paper sets, and I can tell you from our own user studies, it's all the same when they're working online, you get 5 seconds. They look at your name, Dominguez. You want to be an engineer and your name's Dominguez? That's a bad decision right from the start. We're going to look at all of the recent data released by Google and LinkedIn, Facebook, and everyone and see Hispanics are not well represented. In fact, they aren't even as represented as well as they are in this population of computer science students. Where did you go to school? Nowhere. Where have you worked previously? Nowhere. 5 seconds and into the trash. I'm not being critical of recruiters. And when you see the kind of pressures they're under to find talent, they don't have time to dig deeper in, and quite frankly, they're not trained to do so anyways. They're not an engineer. What are they going to do if they knew that he wrote code that, in fact, their companies might actually be using if they're a Ruby shop, which is they probably are because that's probably why he applied there. So nothing for a year. Self-taught, Ruby programmer, real talent, going nowhere. This is Duncan McGregor, which when I see it always makes me think Duncan McLeod, and there can only be one. This is an appropriately aged audience for that to work. At my office, one of my coworkers once said, when I was little and on Facebook, and I realized, God damn, I'm so old. So Duncan has a much more eclectic background. Some of this is a little secondhand, but he's an interesting guy. He dabbled in physics. I think he actually spent some time getting a degree in physics. He was a professional monk in Bhutan, whatever that means as being a professional monk. He was in special forces for a while, did all sorts of things, and along the road taught himself how to program. Now, this guy had a real following in open source. So he's sort of a known quantity. And again, a lot of the companies he might be interested in working for were probably using code he wrote. And he would apply there, and they would respond, yeah, we could use a junior programmer. Come on. A junior programmer? Your system's based on what I wrote. He knew what his value was and knew that no one was interested in hiring him at that value. And we're going to go into why it's easy for us all to guess here. The fact that you're in the room probably means somewhere on your resume or CV it says the word Berkeley and possibly some other fancy schools. That's what you need on your resume to get noticed. But we'll come back to that. I could spend a lot of time talking about a variety of issues, and some of which I will come back to in the future. I'll skip the lean in. I'll come back to the marshmallows. The name on the resume, I'm sure all of you are familiar with. What really hurts my heart about the studies of name comparisons on resumes is that many of them are done in academia. And you'd think if there was any place where you would see a lack of bias, it would at least be in the meritocracy of academia. Most recent piece of research got a bit of press coverage, came out over the summer from Harvard Business School. They sent an email out to professors requesting an hour of their time, either a week from now or that same day. And it's kind of phrased as in, I might be interested in being a graduate student of yours. Can I grab an hour of your time? The only thing that differed from email to email was the name on it, which was either male or female. And forgive me, these are broad strokes, but it was the terminology used in the paper. Black, white, Chinese, Indian, or Hispanic. And, oh, God forgive, if you're a Chinese woman, your chance of getting a response was 77% less. Just a response, not even the no, just the response was 77% less than white male. And in fact, for that week out response, and in fact, everyone, as you might imagine, is down. On average, your chance of getting a meeting was 24% less if you were not white male. And the disappointing thing is it is mitigated if the person you were writing was the same race and gender, but it still was below the gold standard. The fun part is your chance of getting a meeting with them is higher if they're at a public university, and it decreases, I believe, 3% for every $4,000 in salary they get. So here's the one thing I can give you as a takeaway, a fun finding that goes along with a lot of psychological research, is that only applies to the request for a week from now. People that were asked for an appointment that same day, there was no effect of race or gender. And the research that it agrees with is a variety of research that shows that under time constraints, people's decision-making processes typically are simply about availability. Oh, God, am I free? Yes. Whereas if you give them a week to kind of think about it, then they think about whether they actually want to meet with you. And like I said, there are problems with that. And like I really said, the most disappointing part of the whole thing is that these were professors. Okay, so I do a variety of things. I dabble a lot. I'm going to talk about two of them here today, one broadly and the other a specific project. So the first is architecting better companies by unleashing human potential. This is the purpose statement of Gild, which I'm thrilled with because they stole it from one of my talk titles. So here are some basic stats. There are about 10 million software developers worldwide. This is estimates from the Department of Labor. I can roughly agree with this number because I have all of them in a database. This number's old because I'm too lazy to update a slide I put together a year ago. Because this is growing so fast, there are probably more like 3 million professional software developers. I'm not saying there are 3 million people that know how to program. There are more than that. But there are about 3 million professional software developers in the United States. That's how the Department of Labor would categorize them. So where do you go to recruit new developers, right? This is a big issue. Listen to the news all the time. There are not enough qualified technical talent. We need to increase our STEM pool. Where do you go? Say, if you're not Google, and Silicon Valley's scorched earth. Well, let's focus on Google to start with. What was their original solution? The marching orders from the founders. Top 5 schools. Just so happens Berkeley is one of those. I can tell you from our own system, we'll toss in a few algorithms as we go along here. We built this really cool model, ripping it off largely from someone else, but still, I really like it. We just take a graph where we can look at people and companies and universities. We model heat diffusion through this network, and with a couple of starting assumptions, we can replicate rankings of universities, graduate school rankings of universities in any domain in about 5 minutes, rather than spending all the time that US News and World Reports do going and polling people. We can produce that in about 300 seconds. So that gives us a sense. What are the best schools? Well, for programmers, the best schools, according to our rankings, are Stanford, Caltech, MIT, CMU, and Berkeley. Simple. We're only going to hire from those. I'm going to come back to that list in a moment. We're only going to hire from those. That was, in fact, the marching orders from the 2 founders. And interesting enough to know that neither of them spent their undergrad at one of these schools. So only hire from the best schools. But there are a couple problems with this. One is simply, these schools aren't turning out enough employees. I mean, nowadays in the tech industry, spread over the United States, just Silicon Valley, much less all the United States, much less the rest of the world, there simply are not enough engineers coming out of top schools to fill these ranks. In fact, you could add up, it helps that at least one of those schools is a public university and we have a little bit more throughput, but even adding up the entire student graduating populations, that's not enough to feed the hunger in Silicon Valley, and it is a crazy hunger. But here's the first thing I learned as chief scientist at Gild. The punchline, what we'll get to eventually, is we devised a system to do an unbiased rating of developers, predicting how good they are at coding in the language of choice. So that means I have this system, which is nominally, although I will acknowledge, imperfectly, unbiasedly assessing people's coding abilities. Well, let's look. Of all the top credentialed people, they went to a fancy school, they work at a fancy company, and in fact, we say they're really good. How many people are just as good without those credentials? Well, our finding was it was roughly 10 to 100 times as many people. Now, I will be perfectly honest. Your signal to noise in those top 5 schools is much higher than the general population. If they got to Stanford, if they're here at Berkeley, they're much more likely, if I picked one at random, to be in our top performer population than from the general population. But your false positive rate is crazy. Unacceptably crazy from a social justice standpoint, if you ask me, and a market distortion from a broader economic standpoint. Okay, so we have that, but are these really the best people in the first place just because they have these fancy degrees? Let's talk about Google Discovery number 2. Yes, Google Discovery number 2, or number 1. Secretly, behind the backs, you probably have heard of this, their HR team, which is called People Operations there, did an experiment to figure out what is actually predictive of success inside Google. And they literally had to do it behind the backs of the founders. And what they found is, in fact, where you went to school is not predictive of anything. Now, let me be clear. If that were the sole variable I had, yeah, that would be pretty strongly predictive. But if I know a lot about someone, say they worked for me for 5 years, wow, that's not predictive of anything. Once I know the other factors that are, where you've worked before, marginally predictive, at least over the near term. Your grades, that's not predictive at all. Your SAT score is not predictive at all. So what is it they discovered? Well, really, they're kind of like Columbus. All they did was discover that there were people already in this research space, which is in education. It's something we've known for decades. And I'm just going to pick out one example. My wife and I are trying to coin a term called meta-learning. But one snippet of that is motivation. And at Stanford, Carol Dweck does research and uses the language of a growth mindset versus a performance mindset. A slightly more wonky terminology is endogenous versus exogenous motivation. Does your motivational structure come from within you? Say in the case of a student, this is someone who's just innately intellectually curious. They just go and they research. You're Bill Gates, all you do is read books all day. Or are you exogenously motivated? So you like the praise. You want to get good grades to show off. You're afraid of punishment. Well, it turns out as a population, the endogenously motivated students significantly outperform the exogenously motivated ones. And in fact, a paper just came out this summer looking at students at Annapolis, not only at their graduation rates, but their career outcomes. Who actually reached the highest rank? Who became, a lauded naval officer? And not only did grades were a perfect predictor of graduation rate, but endogenous motivation was far and away the best predictor of their career outcomes. Exogenous motivation not only was a negative predictor of both graduation rates and career outcomes, if someone held both of them, so in other words, they're trying to show off at the same time that they really care about the Navy, it undermined their performance. So what did Google find? They find, actually, the truth is, some exogenous motivated people are very smart, and they go to Ivy League schools, and they get hired by Google, and the performance of their team drops. A little bit, but enough to be measured. Why? Because they're interested in the corner office. They're not interested in the project they were given when they started. They're a very clever person, but their motivation is not aligned with the needs of the company. So that's what they found. I will add in, of course, the famous Google interview test, the brain teasers and everything. That was their attempt to try and get at these, what they felt were kind of intangible qualities. And then, interestingly enough, just Google's discovery number 2 is those aren't predictive of anything either. I can tell you why really clearly. Go Google how I got a job at Google. And you will find blog post after blog post of people cramming for the interview, studying all of the brain teasers, studying every search algorithm so that when they get asked to map out some A-star search thing, boom, they do it. And they look great. Versus, forgive me if any of you really do know, but very commonly people get brought in for data science interviews, and they're given an engineer test instead, and they have to, oh gosh, search, I guess you kind of do it this way. They stumble their way to the answer, and the person's not impressed. Well, guess what? You end up hiring for the exact same thing you end up selecting for in terms of SAT scores and GRE scores, which I already told you are not predictive of anything. I bet if you deployed those tests at random on the street, they might actually be informative. But as soon as you create this artificial incentive structure around it, you get a behavior which is not aligned with your actual goal, which is let's find people that are endogenously motivated. Okay, so these are the problems with the existing approach. So if on Jade's resume it had said that he went to Berkeley, he'd have gotten a job immediately. And that is what that's what people use Gild for, which is crazy because they pay us a lot of money specifically to not do that. And then we did user testing that found the first things that recruiters were looking at when they opened up a profile in Gild was, what's your name, where'd you go to school, and where'd you work before? The exact things that we have been paid to get them around. All right. So what does Gild do? We mine, here's where we come to a little data science. We mine through about 100 different websites around the internet. And our particular focus is English language, but is the nature of the engineering world that covers a huge percentage of the engineers that are at work of interest to our customers. Some of them are obvious, like Bitbucket and Google Code, and of course GitHub. We started there. That was the original idea of our CTO, is let's algorithmically assess every line of code that's out there in the world. And then, hard part turns out not to be that algorithmic assessment, but then assign that back to an actual person. So we know that this line of code was written by someone, and we're confident that it was this person that did it out there in the world. Now, make life even more difficult. Let's do that for 100 different websites. When on LinkedIn, you're Thurston Howell III, and on GitHub, you're Crankosaurus, and we have to figure out that that's the same person. Turns out that that became one of the biggest engineering challenges of the company, entity resolution. But it also turned out that simply having a database full of open source developers wasn't enough. One of our early customers was Google until the New York Times said that they were, and then they dropped us the next day. A lesson learned about publicity with big companies. They took our system, and we had about 300,000 people in it, and they literally came back the next week and said, we need more names. So that gives you a sense why the graduating class of the top 5 universities, or top 20, or top 100 is not enough. So then we expanded. I was brought in as chief scientist. We built a data science team. We need to be able to take that code, and instead of having it be our product, we need it to be a training set. 300,000 people makes a pretty good training set. If we pull in data off of 100 different websites, maybe we can look and see what's predictive of the people that write the best code. A great piece of use for that is Stack Overflow. Probably everyone here that's ever had to work on a coding project has pulled up something on Stack Overflow. I am not a developer, but every now and then I would like to throw a little project I'm working on into a Flask application or something, so I go Stack Overflow all the time. But there's a ton of information on LinkedIn, an obvious competitor, and Google Plus and so forth. So we pull all of this stuff in. We now look at about 54,000 variables. Those were selected out of millions of variables in terms of finding some initial predictive power we could hang our hat on, then refining and refining and refining, because it just isn't, for a production system, it wasn't really realistic to think that we could even run some simple sort of sophisticated logistic regression off some massive system at the rate that we needed it. So a little bit of selection process, like I said, mercenary. Anything that would work anywhere. We have a little factorization here. We have a hierarchical mixture model over there. Anything we can get to work. If you're curious, our production world runs in Mongo with Ruby, but the data science, we just couldn't work with that. So we put everything together, our own platform. Any of you thinking of starting a company or your own data science team, just build your own platform. Whatever you want, it's fine. It's going to be better than what the engineers are using for the purpose of data science. So we built it. It was Cassandra and all Python-based. All right, so we pull all this stuff in. There's a problem, though. I told you one of our great sources is Stack Overflow. And as such, that number right there, 65, let's be lazy. That's so great. They're telling me who are the best people on Stack Overflow. Or I could just look at followers on GitHub. Easy. Oh, my God. I got to go faster. So some of you may be familiar with this paper. I'm probably not going to get the title right. It is from like 2005, 2006 science paper. And I believe it's called an experimental analysis of inequality and unpredictability in artificial virtual markets, which sounds very dry, but it's a cool experiment, sort of like early data science-y stuff. They partnered with a real new music site in which users of the site, new users, would come in and sign up, and unbeknownst to them, were randomly assigned to one of 9 virtual worlds. I'm going to very much speed up and paraphrase their findings, but in one of those worlds, you saw a random ordering of songs to listen to. You chose one, you gave it your own rating, and then you saw, again, a random ordering of songs to choose from. In the other 8 worlds, the ordering of the songs and their average score was available to you. So what happens? From world 1, we learned that there really is good and bad music. People generally agree. That's panel A there. If 3 people liked a song, the 4th person probably likes it too. High scores, out of a 10, we're talking about maybe 5s and 6s. And there really is bad music, or at least we all subjectively agree that something gets a lower score. But it's a pretty modest effect. Panel C, what happens when people see other people's scores? bam, big, huge nonlinear effects. Suddenly that good music is great music. You actually somehow start to see average scores of like 9s and so forth. Suddenly the Beyoncés of the world emerge, but only when it's a social environment. Okay, that's bad, but it looks monotonic. I can just squash that back down to its original linear form, or use some more sophisticated way of dealing with that. That's the third and final, from the title, unpredictability. Turns out, across those 8 virtual worlds, completely disjoint sets of songs got that nonlinear boost. Same populations, random assignment. All of this was going on at the same time. Completely different songs suddenly got scores of 9s and 10s in one world and never in any of the others. And different songs would get those 9s and 10s. And what they characterize it as, and a lot of research since then has backed it up, some cool stuff, in fact, with Kickstarter, for example, is that this is just a chaotic process, and it depends on how people come into the system and when they happen to see a song. You just get this essentially prime the hat of the Husker sort of effect, where you come in, someone just listened to a new song, gave it a high score, you liked it too, you gave it a high score, and now it's suddenly appearing at the top of everybody's list, and everybody's giving it a high score. In fact, there was a piece of research recently that showed that experts, in this case scientists, providing reviews, even in anonymous contexts, their reviews were biased in favor of what they believed their other experts would be saying. So you don't even truly need an explicit social effect for this to come in and distort the results. Okay, so we can't rely on that. What do? We actually go in and do semantic mining and sentiment. And so we actually look at the questions and answers in Stack Overflow and mine through them, looking for certain entities and certain sentiments. And then on top of that, we added in this incredibly simple algorithm that turned out to be really robust, which is, let's just assume the person answering the question knows a little bit more than the person asking it. And that gave us a unidimensional embedding, which is just a ranking of everybody. And it turned out we then tested that against user sets, and it did a really good job of ranking everyone. It's not perfect. It didn't agree perfectly with users, but it was good and integrated it in with every other piece of information we had. It turned out to be really valuable. So complex problems sometimes have simple solutions as long as you step outside the complexity. So what did we find as some of the predictors of interest? These are just fun little things. So C/C++. This is such a common skill for people to claim that it is part of the drop-down menu on LinkedIn. So what does our system say about it? You want to hire someone to do some C programming for you? Don't hire this person. At least at a probabilistic level, although this is pretty robust in our population of data, when we look at all the best C code, all the best C++ code, those people list separately C and C++ if they know them both. If you are a professional C developer, that would be like saying, oh, sure, I know Spanish/Portuguese. You know, it's not how such a person would think about the problem. They're two separate languages. However, if all you've done is taken a course in C while you were in college, let's say, then you probably heard, yeah, there's this thing called C++. It's an object-oriented version of C. It's very similar. And you think, okay, I know C and I know C++. Truth is, what we know is you don't actually know either, not at a professional level. Whoops, I do need to get onto that other one, but I'll kind of motor through here. Here's another thing. This is very free-form text, so we mine through Twitter feeds as well. So this person's saying celery is awesome. And they're demented, they're wrong, celery is disgusting. But apart from possibly having some sort of insular infarction, they could be a developer, maybe a Python developer. Maybe they're talking about celery, the multiprocessing toolkit for Python. And now we have the beginnings of a probabilistic graph. Actually, we have the complete probabilistic graph, but we have the beginnings of seeding that graph. So they know celery, then they almost certainly know RabbitMQ or Redis as the messaging platform for it. They're probably using it for Pythonic web application, very common, like Flask or Django. And even though they didn't use the word Python, they almost certainly know it. and think about how well just your intuition, someone who says this, knowing that it was celery, the toolkit, versus someone who simply listed Python on their resume. Guido van Rostrum probably lists Python on his resume if he actually has to write a resume. So really qualified people would, but where do you think the mode of that distribution is? Same as C. It's everyone that's ever taken a class in it, no matter if they haven't touched Python in 10 years. So saying Python in your resume is highly uninformative. Saying something like this with strong sentiment at 2 a.m., and we track when it happens, to a group of people that for some reason you think could possibly be interested in this, some obscure toolkit that solves a deep technical problem with Python, that is someone that cares. Someone who's endogenously motivated. It's just one clue. We don't literally know that, but it's a clue. And we look across 54,000 clues for that sign of endogenous motivation. Not intentionally. All we're looking for is people that write great code. But it turns out the people that write great code typically show all of the signs of being endogenously motivated. No one's asking them to do this at 2 a.m. No one's asking them to push code at 2 a.m. No one's asking salespeople to make sales the day after the close of the sales cycle. In fact, the VP of sales may yell at them for, why didn't you close it yesterday? I got to go see the board. They do it because that's who they are. And in the long run, those people outperform. So here's what you get when you actually open up a profile in Gild. We have the score of expertise, which is our sort of internal score, market value, what we actually call demand now. We actually built the whole score of a traditional scoring system. So, if all we knew was someone went to Stanford, we would give them a 2 in expertise. It's a predictor, but a very modest one. We'd give them a 4 in market demand. We use the exact same data feeding into it, the same feature set, totally different weightings of the two of them. And then we have some fun stuff where we actually take a little narrative algorithms and we look at the factors that drove our scoring and present both in graphical form the broad categories that drove the scoring and then a narrative form. Because remember, we're presenting this not to engineers, we're presenting it to recruiters. And we need to explain to them why they should hire this person. It's not enough just to have a score. It does make it really hard if we want to use the new hotness, because things like deep networks are not great at providing explanations. There are things that they're really good for, and we actually play around with things like word to vec and paragraph to vec for some of our internal stuff. It's really cool. I want someone like Francesco, our lead backend engineer, plus Neha, or minus Neha, a backend engineer, plus Jade, little preview, our lead front-end engineer. What do I get? Or a front-end engineer. It turns out it starts returning lead front-end engineers. So if you know word to vec, that sort of, it's just neat that it actually works with people. You can do algebra in human semantic space. All right, I really want to go on to the next stuff because it's incredibly cool and it's my real passion. But this is important. We're able to identify imperfectly. I make no claims that we are perfect. For example, open source is highly biased in favor of white males. If you're an older worker, you're less likely to be represented there. If you work in any industry that has security clearances, you probably don't submit to open source. A lot of that is the reason why my team came in to build these predictor models, so we could look at everything else about someone and predict great code. But inevitably, there would be biases. I'm just telling you that compared to what we know the bias is in the system right now, I'm happy to put my kids into here for their future, as opposed to taking it as it's currently done. But when this first was publicized and we got some coverage in a variety of publications, I got some hate mail, nominally, academic version of hate mail. You're just whitewashing the problem. What about all the, Jade is awesome, but how many people teach themselves how to code to that level? What about all the people that never had the chance? I felt particularly hurt by that because one, frankly, it's not Gild's problem to solve the world's problems. At least we're doing something. But the other is because I do live in that space. I do work in that space. And I'm just a little annoyed that the person didn't know it. So I have another company called Socos, which I co-founded with my wife, and in fact, a former student of mine here. And it's an education innovation company. And one of our projects, which I'm going to talk about so quickly here today, is called Kindersight. And I have the coolest announcement in the world. In mid-October, we're going to go to Washington, along with the Clinton Global Initiative and a group called Too Small to Fail, and do a joint workshop and announcement with the White House on part of the Solving the Word Gap. So data science, every point here is a post in an online discussion forum. I'll come back to that. This is my wife and I giving a keynote at South by Southwest EDU, where I threw out this idea on stage. What if we put a little micro-recorder on every kindergartner? And every 10 minutes, we grab 30 seconds of audio of them, of their classmates, of their teachers. Hey, how about even out in the playground? How about at home with their parents? And so this was in Austin, and this woman named Jenna Dare had an email, was waiting in my inbox by the time I got back to my computer, and it said, I can do this, I want to do this, and I want to get started today. So here's the problem. Actually, the problem is bigger than this. This is one tiny sliver of the problem. By age 3, there's a 30 million word gap between high socioeconomic status kids and low socioeconomic status kids. I'm obviously not saying 30 million unique words, but in terms of the total volume and those high SES kids, it's more complex and it's more directed at them. And there's good evidence that this is a causal factor in those high SES kids outperforming early in their lifehood and essentially carrying an advantage on through into adulthood. There's such a cool, if anyone has questions, please ask about Kingston, Jamaica. So there is, in fact, such a project working, you may know, it's Berkeley, you probably have heard of this study, but Providence Talks, they're doing that. They have little recorders, there it is, it's very cute, that they stick into preschoolers and kindergarten kids, and they record everything they say. The problem is it's not in real time. It's not actionable. All they're doing is describing the problem. And some of the people that we've worked with have been a little bit disappointed about what comes out of it. But it has confirmed this is real. There are serious problems. In fact, not only is that 30 million word gap real, but a lot of the words that the low SES kids are hearing are on television. They aren't even socially engaged words. And I can tell you from my own and others' research that that is cognitively completely different. And there's a huge additional cost. Okay, so what do we do? This is from Tom Griffith's paper, along with a variety of other people, but I'll give credit to the local boy. This is a hierarchical latent Dirichlet allocation, an example from their paper in which they applied it, I think, to something like NIPS papers or science papers or something like that. And you can see that this unsupervised learning system is able to build a hierarchical representation of the concepts in biology. And that's neat, and that's exciting. When I talk to a crowd that's not nearly as sophisticated as this, it sounds like black magic. That's what VCs say all the time. This is black magic. You can read kids' minds. Here's $2 million if you do financial fraud detection. So we took a model of this and added our own bells and whistles and a front end and back end of my own design, and we applied it to University of Phoenix kids. So these were students, undergrads in an online biology course, and MBA students in an economics course, about 20,000, 30,000. It's all online. The only thing we looked at was their online discussions with one another. That's it. We trained on that. Then we layered a just logistic regression on top of that to predict their course outcomes. Then 20,000 new students came into those two courses with new instructors and new assessments. And I mean, this is 100 dimensions squashed down to 2. Turns out it's highly separable. Week 1, we knew what grade they would get for 99% of the students. By the end of the course, we knew within 2 points on their 100-point score what grade they would get in the course, and we had a pretty good idea of what they get wrong or right on individual questions on the final exam. We learned biology from the students, which turned out to be incredibly crucial because it was all the good, the bad, and the ugly. We learned all the misconcepts. We learned the bad cues. Turns out a ton of what our system learned to be anti-predictive of success was highly normative. We'd see this evidence of students having appropriate discussions about collective bargaining agreements in nurses. Well, it turns out that was a piece of anecdotal research that came up over and over again in the course. And what our system learned, without explicitly knowing it, was that the students were regurgitating that material onto the exams and into the discussion forums to cover up the fact that they didn't really understand the underlying concepts. So they were entirely normative. If you scored them, you'd have to give them full points. But our system didn't, because it learned that they were off track. And of course, the whole goal here is if we knew at week 2 that 5 students in week 3 weren't going to get a certain concept, we can then communicate that directly to the teacher and have them do an intervention that might resolve that. All right, so what can we do for kindergartners? Well, we're launching. So what we're going to do for them is the following. On top of making recommendations, but we've changed it a little bit. Think of all the work that goes on in your classes all the way through down to kindergartners. That's just heat loss. And it all boils down to a high-stakes exam at some point or maybe a big essay. What if you could take all of that naturalistic data, and turn it into a formative assessment that the teacher could act on in near real time? And better yet, I've already told you your grades aren't predictive of anything in your life outcomes. Let's align that formative assessment with life outcomes. Let's look for the predictors and all of that unstructured data that actually say something about health outcomes, income outcomes, socioeconomic outcomes for students. I didn't do the marshmallow test. Someone asked me about the marshmallow test later. That's what we're going to do for the kindergartners. So on top of delivering intervention recommendations and a relatively sophisticated dashboard to a teacher, we're going to be working, these are migrant kids. They're Spanish speaking at home and English immersion classes. We're going to send a single text home to their parent every day. Here is the single best thing you can do today for your child. And it will be a live experiment, and many of them will have permission to record at home. We'll actually be able to record the event that we made the intervention recommendation on, and then over subsequent day, week, month, see if, in fact, it has the effect that we're interested in seeing. But also personalize it. If the kid was excited about seahorses, then our text today is a relatively sophisticated thing about meta-learning or grit or one of these elements that we want to drive, but we put it in the context of seahorses. We're really excited, and we're doing this big release. And it doesn't stop there. These are just side projects of mine in autism, bipolar disorder. My son has type 1 diabetes. In all these cases, we've built platforms that follow the same concept. Take naturalistic data in the world, out in the world now we think of that as wearables, but turn it into some kind of predictive assessment and provide not data, but answers back to people. And do it all without a single test. And that's what we're working on. And on the concept of wearables, you probably want the closure to the story. Jade, he used to be our senior front-end engineer. Now he's off doing his own thing. I'd love to say what a lucky guy that we found him, but we're the lucky ones. He was the one that had the talent. Our algorithm said he was the second best Ruby developer in Los Angeles. And Duncan eventually got hired by Rackspace, not Rocket Space, to become their senior software architect. And he brought 5 people into the company with him because, like I said, he had this huge following in the open world. And subsequent to discovering him in Gild, they found out that his resume was in their archives. They'd already overlooked him several times. So again, we're not doing them any favors. We're doing us favors. And so there now, finally, speaking of wearables, here's the first ever Google Glass portrait of the president. It apparently is much better for taking pictures of naval officers. But let me tell you this, he thought I was a crazy woman. I mean, the look he gave me was, I will treasure that for the rest of my life. So there's a ton of things that I didn't go into technical detail on, and a lot of things I didn't get a chance to go into at all. So, but I will stop here. So thank you very much.
So you should ask lots of questions right now. But first, I'm going to just say we're going to have a couple minutes for just general questions, and then we'll break and let people go, in a couple minutes if they want to go, or stay for some slightly more structured discussion. So if you have particular questions, we'll go over that for the next few minutes.
Hi, I really enjoyed it, but I was wondering, how do you rank in the Gild system? I imagine you've looked yourself up. Is that something that
I have looked myself up. One of the things, it was designed to find developers, and I am not a developer. I don't have any code. Actually, ironically, I use Bitbucket behind a private bucket, so none of my code gets assessed. Nonetheless, because of a variety of heuristic factors that we put into the system, the papers I've published and so forth, I have a pretty good score, which would actually, I will be frank, would over-assess my ability as a developer. In the same way, one of the early versions of our system, we went to a company called MapR very early on, and we said, we want to demo this project for you, and they started looking up their own employees, which was very awkward because that is in fact how you'd use it to recruit new people. You wouldn't just say, oh, look up this person. But that's, of course, almost inevitably what mid-level engineers do. If there's a mid-level engineer in the room, they want to look up their friends. Because you want to decompose the system. You want to find out where it breaks. And sure enough, once you start looking up outliers, oh, I know, the guy who developed Scala, and he's like paranoid about being tracked online. Sure enough, you look up the guy who developed Scala, and we give him a crappy score in Scala because we don't have any data on him. He's a huge outlier. But interestingly enough, in their context, all of our highest rated people for them early on, the guy was so dismissive of them. They're all talkers. They're not doers. And that was one of our original clues that the social signals were really bad. Because the people that get the highest votes on Stack Overflow are people that answer questions from me. But the people that answer the toughest, hardest questions, well, most people don't even understand the question, much less the answer. How are they ever going to accumulate votes? So there are inevitably imperfections and flaws. I'm overrated. I am a good scientist. And for Socos, I built the whole platform, but believe me, only because I had to.
So I think Jazz has a question.
There was a question back.
Yeah. So you mentioned there are two types of employees. Sorry, I'm not a native speaker. I missed the two words. But do you see a chance for the transition between the two types?
So that is the purpose of Socos. So we're working on a trio of white papers solicited by the White House right now. The first one is simply saying, what can be done with children? So I don't think anyone here would be shocked at the claim that I can take a 3-year-old and build in them the belief that hard work will pay off. But can you do it with a 20-year-old or a 30-year-old or 40-year-old that maybe has a really rigid beliefs about the world? And I'm not saying explicit beliefs. I'm really talking about like the dopaminergic system. Well, my claim is yes, you can. And although it's a very imperfect example, I don't think anyone here would have a problem with me saying you can train your workforce that their hard work won't pay off. But we do that all the time. You ever worked at Yahoo? So I'm not, the world isn't guaranteed to be, perfectly isomorphic or isotropic or what have you, just because we believe it can go one way doesn't mean the other. I firmly believe it. Let me give you an example. Here I'm going to come in. I'll do the marshmallow test. Again, this is with little kids, but I firmly believe this because I'm going to go into the neuroscience. So here's the marshmallow. Everyone heard of the marshmallow experiment? A lot of people probably have. So it's very simple. This isn't, in fact, how it originated, which is another story. But the modern takeaway is stick a marshmallow in front of a 4-year-old. You say, I need to leave the room. If you don't eat that marshmallow, when I get back, I'll give you a second one. You get 2. So for some kids, the experimenter turns around. They hear a noise. They look back, and there's just like an empty spinning plate. In fact, for the largest single population, it's kind of like that. For some of the kids, they last and they last. And the videos of this, screaming at the marshmallow, or with the cake, because they do it at variants. turning their back to it, telling themselves stories. Interestingly enough, it's a cruel experiment. Every kid breaks in the end. And the ones that last the longest last about 20 minutes before they end up eating the marshmallow. And then every kid gets the second marshmallow. That's the way we do it in psychology. No consequences to life. So that's the marshmallow test. Originally, it was supposed to look at differences in executive function development between 3- and 4-year-olds. But what the experimenter realized, talking with his daughter years later, a bunch of her classmates had been in that original experiment. And the ones that were doing well were the ones that had waited. And now the big takeaway is emotional intelligence. Huge predictor. It's a legitimate predictor. You wait to eat that marshmallow, you will earn more money in life. You will have lower healthcare costs. You will achieve more, and you're more likely to move up in socioeconomic status. So, simple takeaway, we're going to run the marshmallow test on everybody. The ones that wait 20 minutes, we're going to send them to Kindergarten. And the ones that eat the marshmallow right away, we'll put a shovel in their hands and we'll start them digging ditches. Because really, shouldn't they be good at the job they're going to be doing? Well, I mean, just as a social justice issue, of course it's legitimate and I'm being bombastic. But if it's genuinely predictive, well, here's a variant of that experiment, which is probably a lot less known. Before you get started, the experimenter goes to the kid and he says, we're going to get started really quick. While you're waiting, I got a piece of paper and a box of crayons. Why don't you draw some pictures? They open the box and it's empty. And the experimenter says, oh my gosh, I'm so sorry. Let me go get you some more crayons. For half of them, they come back, they give it, they take out the crayons, they draw their picture, they do the regular experiment, and the results are largely like the traditional. For the other half, the experimenter never comes back. Or in slight variants, they come back and it's got like smashed up, unusable crayons in it. All of those kids eat the marshmallow right away. It's random assignments. Some of them would have waited. Why? It's because all of the kids in all the variants are acting rationally. I'm not saying they're explicitly acting rationally, but they're simply playing out their belief that the hard work of not eating the marshmallow that's right in front of them will pay off. And for the vast majority of kids, the lesson in their life up to that point in 4 years is an adult says they're going to bring me a second marshmallow? That's nuts. If I don't eat this one, my brother will. And again, I'm not saying they're explicitly reasoning this out, but rather as a neuroscientist, what I'm thinking is basically the delays between the initial dopaminergic surge and the little dip that comes when you don't get your expected delay. It's a very narrow window with these kids. They simply have not been, either by benefit of biology or of developmental environment, they are not learning that lesson. That is what we're doing with Kindersight. And I fundamentally believe, and we're doing this with a college called College for America, which is part of Southern New Hampshire University, which is the largest online nonprofit university in the world. We are trying to do that with adults. Yet to be proven. The point of Gild is simply we can discriminate between them. The point of SOCOS is we can do it. We can put it into people.
Before you go, I'm going to release everyone who needs to leave before the sort of structured discussion is 2:05. You can still make it to whatever Berkeley time events you must make it to. We'll turn around before we go on. No one's looking. Thanks everyone for showing up. This is the first time that we've done one of these talks, like Kevin said. And as we go forward in this structured discussion, we're going to be sort of testing out the experiment of how such a structured discussion should go. And so by participating, you can help determine whether this is a good idea or not. I will let Jazz ask a question, and then I have a question, and then we'll open it up to all you guys, and we'll just keep discussing until about 2:30. Does that sound right? Okay, so go for it.
All right. What Gild has is this great data, right, because of the open source archive. So you observe people get hired and don't get hired. So like the Google report on like the brain teasers and stuff, maybe there's a more recent one, but the original one was like pretty terrible, right? There's like 3 errors of inference that are very standard. An example I'll give is, so there's 2 departments at a very elite private university, graduate departments. You're trying to, one's technical, one's not. If you want to predict who's going to do well in the technical department, the verbal GRE is very predictive. The quantitative GRE is unpredictive whatsoever. In the non-technical department, the quantitative GRE is very predictive. The verbal GRE is utterly unpredictive. And the reason is, of course, in both the technical departments, highly selecting on the quantitative GRE. There's almost no information left. And the reverse is true in the qualitative department, which is to say, if you select on brain teasers and you do a good job on that, and everybody knows that everyone's adapting to that, I would expect brain teasers to be very predictive of the people hired, right? It's a separate question.
How good are they a year later?
No. So
but no, I'm just
in
saying
the world,
that was the metric that they were using.
But that's right. But that's not going to be right. But the question is, should you use them? Mm-hmm. I mean, in the extreme, it's sort of be like, so at Berkeley, your SAT is very predictive of your college grades. At Caltech, it's utterly unpredictive. And the difference is Caltech is cutting for undergrads at such a high level that there's just no information left on the table. At Berkeley, it's very predictive. You know what I mean? So it's like this well-known issue, right? If I'm selecting on a dimension, I'm going to kill its predictivity. That doesn't mean that in the counterfactual world that I don't select on it, I'm better off. Right? Gild doesn't have this problem because you have like this open source thing, but to transport it with the lesson to this more, these fields like Google where you're selecting people in or out based on something. If you just look at the people you've selected on, it's actually not giving you that much information.
Yeah. So we've already sliced our population, and it's on this specific dimension.
Right.
So
and that's going to,
unsurprisingly, we don't have any variability left in that dimension.
And it's also, we know which direction the bias you're driving it. You're driving it down.
Yeah.
Right.
So I obviously can't speak to the internals of how Google ran that experiment, except to say that they were very confident in the result, that they'd been wasting their years. But for my part, I think that, part of I think it's interesting in their original context of finding out that, in fact, what was predictive is something that, while totally novel to them, is something that another field had known for years. So there's a little validation that their internal techniques were robust or at least reasonable. Whether these things are predictive, given that we're selecting on them, the one thing that I do know is that people were scored in ranges. So coming out of these tests, people were given rating. It's supposed to be a nominally standardized system, which of course is immediately going through the subjective judgment of whoever the interviewer was. But there was some scale to which people were applied. What amazes me is, and I had this issue with one of my original members of my team, was he said, well, we should just build a model that predicts people that work at Facebook and Google and Microsoft, and then we'll rank everyone based on that. So apart from what I thought was the rather obvious issue that the whole point of our system was to defeat the inherent biases of their selection system, there was also, he thought that the appropriate probabilistic model was 0-1. Either someone gets into Google or they don't. And I said, did you really think from one interview, I could take the exact same person and give them an interview on Tuesday or an interview on Thursday, and there wouldn't be any variability in their assessment, based on having a different set of interviewers or maybe slightly different questions? And I think he felt rather chagrined that he hadn't thought of such an obvious thing, that the variability, the inter-rater reliability is not so great, and that's a problem with hiring. So I'm trying to speculate about what kind of data they might have been using and how confident they can be in the findings about their test. The one takeaway I can say is what I've seen and what they found was that it ends up being predictive for the same sorts of things that other standardized tests are predictive for. So essentially, they created another standardized test, a very fancy one, but essentially another standardized test, because everyone goes to Glassdoor and they share the questions that they were asked, and then everyone goes and starts prepping for the questions. And a lot of companies go through the same thing. And the reason they dropped us immediately is because they didn't want anyone else to, once their name appeared in the New York Times, is because they didn't want anyone else to think that they needed help in their hiring and recruiting. And they're certainly one of the more sophisticated customers we've ever had, with a handful of others. But even then, to think that they had it figured out despite all that sophistication, you're right, we have a benefit in that we're looking ideally at the total population rather than just the people that actually make it through, let's say, their initial sourcing at Google, which is already going to be biased. Although they've removed the hard top 5 school things, Google and Facebook and others still fully acknowledge you get a giant stack. The first thing you do is you make a smaller stack for certain schools and then a slightly less giant stack. And then for that stack, you then look and see, does anyone inside the company know this person already? If you're in that smallest stack, you went to a top 5 school, top 20 school, and somebody inside the company knows you, your odds of getting an interview are vastly higher than someone in the giant stack. And so you're right, they're creating their own limitations in what they can then do by analyzing their own interview process because the bias is built right in. And the bias, we don't have to go into gender and academic background. We can just say your chance of getting a job at Facebook drops dramatically if you had the audacity to be born in St. Louis, because the chance that someone therefore knows you inside Facebook is dramatically less. Forget Kinshasa. And that doesn't make any sense for a company that has offices all over the world. So, inevitably everybody wants to do these things perfectly. I know both the inside of Google and the inside of Facebook, and they genuinely want to do things better. They just don't know how. I'm not saying we're magical, just we've dedicated ourselves to a particular data set. The one thing I can say about our data set today is instead of 10 million people, it's 122 million people, because to get that 10 million, we ended up collecting data on a whole bunch of other people as well. So now, although it's in the R&D phase, we are doing assessments on everybody.
Awesome. Okay, so I'm going to add a question. So first of all, I'm dying to know what my Gild score is. But, and whether or not you're including all the forums that I write emails in and all of the things. But what I am even more interested in is, this platform sounds really exceptional in terms of formulating an alternative metric for a particular skill set, for a particular industry. And so in BIDS, we're very interested, one of our working groups is on alternative metrics, which Kevin mentioned. And this is often in our discussions formulated around the academic situation. So in academia, people with a varied skill set, people who are really good at programming, in addition to being really good in their domain, kind of get ignored because half of their time is being spent in something that's totally unvalued. And so, my ability to get a faculty job is actually somewhat diminished by the amount of coding skill that I have. And so, one of our goals in BIDS is to determine some way to formulate such a metric for the industry that is academia and the skill set that is future academia. Like, we need to start teaching people this. And so my question for you is, could you use this framework for totally different skill sets? Presumably, it's somewhat mercenary, and you've chosen particular algorithms for particular tools for this particular data set. But would you imagine such a tool could exist for this kind of skill set?
So, no, that's foolish. And surely the reason you will never get a faculty position is because you will be characterized as bossy and emotional.
Yeah, that's right.
It's true,
Yep.
statistically speaking. Yes, we can. Again, everything's perfect. So what's nice about developers is we have this wonderful data set, all of the open source data in the world. Gives me a training set of about 300,000 people. That's decent numbers. I remember the days when I thought 30 people was a great training set. Now I have this database of 122 million people. So it turns out a relatively easy group to build such an assessment on. It isn't quite as objective, but if anyone here is under the illusion, or if I've created the illusion that our algorithmic assessment of code is perfectly objective, of course it isn't. We do some stuff born out of compiler theory, psychometric analysis and so forth, but a lot of it we just found we needed some heuristics. We even go in nowadays and do semantic analysis of people's comments because we found that it's actually predictive of user-validated good code. We've gone in and done something similar with salespeople, like I mentioned. Earlier, in fact, you heard me say, what do we see about the best salespeople? We see, technically speaking, what we're seeing is outlier periodicity in their behavior. So, sales cycle. Anyone here who's ever worked at a startup all the way through a big corporation and in any way touched sales, then you will know the sales cycle of most of these companies, which is 90% of your sales come in the last day. 99% are like the last 2 days. So if you're on a monthly sales cycle, the 30th, the 31st is like crazed. We had one month where people were calling we were calling a CTO on her honeymoon in Hawaii because it was midnight. We needed to find someone who was still awake that we could try and make a sale on. We closed the deal just because we wanted to get it booked. You think the person that closed that deal was making sales the next Monday? No, everybody takes that time off. They relax. I just told you 90% of the sales are on the last day, which means very few sales are made the rest of the month. And that the first week afterwards on a monthly cycle, or maybe the first month after work on a quarterly sales cycle, nobody's selling. Well, not nobody. Some people are closing deals in that time. That's that outlier periodicity quality. Who's submitting code after the end of the sprint cycle, after the big product release? In fact, I had this cool experience. I was invited to a Red Bull conference. And yes, I was on the plane down to Santa Monica thinking, why the hell am I going to a Red Bull conference? And sure enough, like half the audience were like sports psychologists for skateboarders and coaches for, wingsuit flyers. And it's like, this is a strange world, but apparently one with a lot of money because they threw a really good party, and I'm glad I went. But while I was there, I caught lunch with a guy named Rodney Mullen. And you can go check him out on TED. He gave a TED Talk. For about 15 years, he was the best skateboarder in the world. Tony Hawk did the big jumps. Rodney Mullen did all like the street moves. And most of the existing street moves, I guess he named. So I grabbed lunch with him. And to give you a sense of what a guy like this is at a Red Bull conference is afterwards, people are like, do you know who you had lunch with? Like, well, it wasn't Michael Jordan. What are you so excited about? But, he's a big deal there. And turned out he was such an engaging and interesting guy, smart and articulate, not what I expected from a professional skateboarder. But what I really wanted to talk to him about was this thing. People aren't endogenous or exogenous, nor are they just on some static, unidimensional thing. At the very least, there's a dynamic to it. If you're totally endogenous, you're probably not useful anyways because you don't care what anyone else thinks. And I know people like this, right? There are probably a lot of them in open source in their underwear submitting things at 3 in the morning. So I wanted to talk to him. So there's a dynamic. Not only are people not one extreme or the other, or at the least it's an extremely sparse distribution at those tails, they are in a dynamic. So tell me, Rodney, tell me about you've defended your world championship 59 times. Well, yeah, I usually don't think too much about the competitions till a couple days beforehand. And then I realize I really want to win. And so I start to focus. And you can see that dynamic swing over towards a more performance mindset, a more exogenously driven thing. This is where endogenous, exogenous, and mindsets maybe diverge a little bit because he wanted to win. But what was crucial was afterwards. Defend your title. So he defended it like 55 out of 56 times and then retired. I guess that's the last one. And I said, so what happens afterwards? And he said, oh, well, Tony and I would go to the after party and we're doing some champagne. And then, I don't know, 20, 30 minutes later, we'd be out back practicing new moves. Just like the best salespeople. Just like the best engineers. When there wasn't an incentive for them to do so, they were still exhibiting the behavior that you want to hire for. Not perfectly. I'm not saying they're the only person that ever sell on the Monday after the close of the sales cycle, nor am I saying they're always selling on that day. But when you start to accumulate data, you see that they're a significant outlier in terms of everyone else's behavior. They're not responding to the external incentive system. They're following their own drive. And it becomes a clue. And once we accumulate enough of those clues, we can characterize them in this population. But here's the interesting thing relevant to what you were saying. I'm saying the same thing as identifying the best salespeople, the best developers, and the best skateboarders. Totally different skill sets. To me, the skills are just the tools that people use to impose their will on the world. And if you're a great Python developer or a master at closing vacuum deals, yeah, I'm not saying, again, not everyone is just the same and we'd all be equally good at everything. But what I care about is that someone is a developer. So the 3 pillars to talent, talent management, which is the technical term for this sort of HR space of this sort of thing. There's skills and expertise, there's personality and motivation, there's culture. That's my own thing. And when people ask me, if you're hiring for a contract, 6 months, you need to get something built, hire for skills. Because they need to start working on the day they show up. But if you're hiring someone for a career, or if you're bringing a student in, or if you're making a faculty hire, perfectly honest, who cares what skills they know? If they have the right personality and motivation, and they're culturally aligned with your organization. I've built such a culture model. I didn't talk about it here today, but coming out of that model, people that are good culture fits tend to stay 60 to 80% longer on the job. And these are like beautiful. I can build these models that predict how long someone will stay on the job. In Silicon Valley, in the tech industry, it's 2 to 3 years. You look at it and you think all I was doing was like plotting the gamma function thing in SciPy. It's just beautifully, smoothly mathematical looking. It actually has a little bit of weirdness at the 2 extremes, which I can come back to. But it's just amazing how predictable people are. 2 to 3 years, everyone turns over. Not everyone, but so many that if you tell me the industry, their age, and how long they've been on the job, I can give you strong odds on whether they're going to leave soon or not. In fact, we're just about to release that product. So given that, if they're good culture fit, they stay 68% longer. Instead of 2 to 3 years, they stay 4 or 5 years. Well, if they stay 4 or 5 years, so that means if I simply hire for skills, by definition, I get average performance for 2 to 3 years. If I don't hire for skills and I take 6 months and train the person for the job, 0 productivity for 6 months, plus the cost of training them, I get 3.5 to 4.5 years of significantly above average performance. And so we can build these models. Anyone done any work in targeting, ad targeting, or so forth, there's this idea of customer lifetime value. So you build these probabilistic models, you predict how valuable a customer will be to you, and then you know whether it's worth it to go after them and what kind of ads you're willing to buy to attract them. Well, we are building this thing, which turns out wasn't an original idea, but I'll pretend it is, called employee lifetime value. If we have this very nice probability distribution over how long they're likely to stay, and we can build an economic model over the value they input into the company, then we can give you the economic value to the company of that employee. And now, all of these years are gone since IBM famously used to train up all of their workforce, we can tell you, no, it's worth it. Take 6 months, because recruiters can't do that. They have to hire someone that will fill the job right now. And I know that stress. I've started 3 startups. Of course, I got to hire someone that can do it right now. I can't train them up. But there are a lot of companies post-startup, and Gild is easily in that space right now with 70 employees, where we should just be hiring the best people and then go find the job for them and train them up in it and stick them in it. So that's my answer to the skill sets. There are things. There are metrics you should be using. And they probably are some metrics that are unique to the field of data science and might be unique to academia versus industry. But it probably doesn't have that much to do with skills, except to say that if you don't know your statistics, your data science is the wrong field.
Okay, who's next?
Actually, I have a question.
Oh, okay.
I was interested to know, I mean, one of the things I'm interested in BEATS as a technographer is to see how people collaborate. And I wanted to have your input on collaboration. Is collaboration a skill that can be modelized as goals?
So yes and no. Gild doesn't have a good insight into that, obviously, because what we get to see is company level and individual level. And so I said, like in our predictive model, there's this weirdness at the end. It's not a true gamma function because there's this point at which it sort of becomes memoryless at the tail. So people tend to make a company a career with some probability. Turns out, higher probability if they're a good fit, but it's still a very small number. And then at the front end, there is this early employee churn, which we can't predict at all. It doesn't seems invariant to our model of company culture. And kind of what I'm guessing, these are uncontrolled variables, things very much like, do you get along with your manager? Within 6 months, people realize, oh, God, I'm not going to stay here for 2 more years. And they leave. And we don't see that at Gild. That's not there at the LinkedIn level for us to be able to pull into our models. But by the research, we know that it's a huge thing. And in fact, what I really would like to do in terms of so I have this dream of Gild on the inside of companies, doing, again, talent management. So same thing that SOCOS is doing in education. Wouldn't it be great if the job you did was your assessment? So instead of an annual 360 in which someone subjectively looked through your performance and gave you a single summary analysis at the end of the year, or maybe quarterly or something, you instead had a little dashboard you could go visit. And you and your manager and whoever else is interested party could actually get feedback, and you'd know whether you were adding to the bottom line. And the number one metric that I think should be used, it might be controversial if you're familiar with the teacher assessment work, are things like structural equation models to say not how you individually are performing, but what are you adding to your team? I don't care whether you're scoring any points. I don't care whether you get any rebounds. I don't care whether you got any steals. If our team wins more games or scores more points than the other team when you're in than when you're out, then you're a great employee. You're a great basketball player. But same sort of thing. If we can build, and we can build structural equation models that can extract the value of the individual as part of the organization, a classroom in the case of these teacher assessments, that's what I'm actually interested in. In the case of academia, what it strikes me as is I've known a lot of people that I think really made their departments better. I mean, fundamentally they knew their material. They knew everything. They were interested in everyone else's work, always asking tough questions and driving everybody. And they were not strong native English speakers. And they were a little shy. And they were perfectionists when it came time to write papers. They're never going to get a faculty position at a major research university. And yet, any department, in my opinion, that hired them would have benefited as an organization. So they're decrementing all of their collective performance at the expense of not having someone on staff that doesn't meet the individual metrics. So I'm very much interested in the organizational metrics, but it's not accessible for Gild. For SOCOS, say with College for America, I actually get to track the inter-student interactions. And one of the things we're recommending is optimal cohorts for students. So we have an incoming class of students that never interacted together, and having just an undifferentiated class of 300 people isn't very helpful. So we say, okay, well, how about these 5, 8, 10 people? We think that they're an optimal cohort, that we're going to get a nice set of upward comparisons and help that's actually going to drive their performance. So there we can track that, and just like with Kindersight, we make some recommendations, and we can almost immediately start to get feedback on whether those recommendations are accurate. So one takeaway, although I don't know how many actual youths are in the room that need any career advice, but one big takeaway is don't sweat making perfect models. Instrument your system for testing right from the start, and get a good enough model that, by analogy, you can find a gradient and just start to perfect things.
Thank you. So I think we probably have to, did you want to do that?
Yeah.
So we probably have to call it an afternoon. It's now 2:30. But thanks, everyone, for coming. I'll hand it over to Kevin, who probably has something.
Thanks so much for coming, and thanks, Vivienne.
Thank you.